Hi guys, good evening. So in the last session, we had seen about how you will configure the lab and base policies we have seen. Now today what we'll do is we will see about access control policies. Okay, we'll see about the concept of ACPs. That is access control policies. Okay, so under an access control policy, we can have multiple access control rules. Okay. Now this thing is kind of similar to your access control list. Okay, where under one ACL you can define multiple access control entries. So like you can say that under one ACL you can have multiple ACEs. So same way you can say under one ACP you can have multiple ACRs. That means access control rules. Okay, so with the help of access control rules, what we can do is we can control the traffic of the traffic that is passing through your firewall, going from inside to outside, outside to inside, okay, or from any zone to any zone. So whatever the traffic will pass will be allowed, not allowed. So those all things we can control using the access control policies. Now let's directly jump into the lab and we will understand how we are going to control the traffic. Okay, so let's access the lab directly. So are you guys accessing the lab, remote lab? Okay, how's your practice going on? Have you practiced about the basic base policies? Still on basic config, one day only did. Okay, no problem. Stop the notes. Close it. Login. Let's power off the. And let's start our devices. Here basic config done. Today we'll try basic policies. Okay, good. Because almost every day we will be doing some new tasks, right? Some new labs. So you don't have to wait. You don't have to put on today's task on tomorrow. Regularly you can practice. Okay, so the devices are up. What about FTD FMC? So this thing we will access using the base PC, management PC. So all I need to access is the inside PC. And then I need to access inside R1. Inside R2. DMZ. Outside R1. Outside R2. And from here, I'll access the FMC, and via FMC, I will manage the FTD. Okay, FMC is still coming up. Meanwhile, we can go and do the configuration of these 5 routers. So this is inside R1. The configuration was not saved. Okay. So let me do one thing here. VPN FTD. Let me open the lab. So this is our lab diagram. Now let's configure inside R1. Host name inside R1. Interface Z1. IP address 10.1.1.25.255.255.255.0. P1 towards FTD. Okay, one default route. Then after IP domain name cisco.com crypto generate RSA modulus 1024. Then after username Cisco privilege 15, password Cisco 981.024, login local, transport into all, IP HTTP server, IP HTTP, secure server, IP HTTP authentication local, and do wait. So inside R1 configuration is done. Now next we will configure inside R2. Enable configuration terminal, host name inside R2. Interface G1, IP address 10.1.1.126. No shutdown. Then after IP route. This is basic configuration right now we are doing, right? Everybody is aware of it. Any doubt in this configuration? IP domain name cisco.com, and then crypto generate RSA modulus 1024, username Cisco, privilege 15, password Cisco. Then after we can say 951 024 login transport input all IPS3 server, IPS3 secure server, IPS3 authentication. Okay. This configuration has also been written. Now DMZ. Enable configuration terminal. Anyone would like to do the configuration? Can tell me. OC. This is DMZ server. Interface G1. IP address 722.1.5. Shutdown IP route 10.10 IP domain name .com. Generate RSA modulus 124. Username Cisco privilege 15 password Cisco. Line main device 024 login local transport input all IPS3 server IPS3 secure server, then IPS3 authentication local. This is done for DMZ. Then after, next is outside R1. Enable configuration terminal. Then name outside R1. Interface G1 IP address. No shutdown. 0. Long 1110. IP domain name cisco.com. Crypto key generate RSA modulus 1024. And then after we have username Cisco privilege 15 password Cisco line visualize 24 login local code input all. Then after IPS3 server IPS3 secure server IPS3 authentication local. Okay. This is outside R1. Let me write the configuration. Did we write here in the DMZ? Yes, in the DMZ we didn't write. What about inside R2 is written? Inside R1 also written. Okay. Now outside R2. Enable configuration terminal, host name, right R2, interface G1, IP address 11.1.126.255.255.255.0. Then say no shutdown. Then after this, IP dot. Then we'll say 11.1.1.10. Enter. IP domain name cisco.com. Crypto key generate RSA modulus 1024. Then we have username Cisco privilege 15 password system in the system. Then we'll say line VTY 024 login local transport input. Then we'll say IPSTDP server, IPSTDP secure server. And then we'll say IPSTDP authentication. So now the router's basic configurations are done. Okay, now from outside to outside communication we can test, and from inside to inside communication we will test. So I say ping 11.1.126. We should have the communication. So we can see we have the communication here. Okay, what about telnet 11.1.126 Cisco system. This is ping. From here we can check ping 11.1.125. And if I check telnet access, uh, 125. Cisco. So this is also okay. So outside both routers are working fine. Let's check the inside routers. Enable ping 10.1.126. We do have the communication. And let me check the terrain. Oh, sorry, I did 11. I have to look for 10 only, 10.1.1.126, because right now my firewall will not allow any traffic to pass from inside to outside or outside to inside. And 1.1.126 Cisco. This is fine. Let's check from R2. Cisco. Okay, everything looks good. So that means we are good to go. Now let's go here and let me refresh it. Advanced, accept and continue. This is our FMC. Username admin, password is 123. Not now. Now here what, first of all, I'll go to device and I'll go to device management to verify whether my device is correctly integrated or not. So here everything looks good, that FTD is our device. By default, right now the access control policy that is working is your block all traffic, and this block all traffic will do what? Will block all the traffic. Then about the interfaces, that inside is there, DMZ is there, outside is there. These are the zones and these are the IP addresses. So now if these IP addresses are up and running, we can just go and test the communication. I can say ping 10.1.10. So from inside my communication is okay. Then I can check from the DMZ also. I can set ping 10.2.2.10. DMZ side also communication is fine. Then from the outside we can test ping 11.1.10. Outside communication is also fine. Okay, and right now if I try to communicate from inside to outside, let's say I want to ping, and I want to ping from inside to outside. So I want to ping to 11.1.1.25. Okay, so right now you can see I'm not able to ping. Why? Because of my default policy. My default access control policy is block all traffic, which is going to block all the communication from everywhere to everywhere. What about FTD outside interface IP? Yes, FTD outside interface IP is here, right? 11.1.1.10. Okay. Do you mean to say, am I able to communicate with the outside interface IP? No, you will not be able to ping. Okay. A firewall will never allow you to ping to other zone interface. Okay, you cannot ping other zone interface of a firewall. Okay, this is not allowed. Okay, now what? Let's go to the policies, access control, access control. So right now we can see that policy right now we are having is block all traffic. So this policy is doing what? This is blocking almost everything. Okay, from everywhere to everywhere. So I'll go and edit this policy. And in this policy, I'm going to go and create rules. Okay. So right now you can see I don't have any sort of rule. Okay. As of now, I don't have any rule. Now, when I try to ping, right? When I try to ping from inside router to outside router, then was I able to ping? Yes or no? No, right? Because the default action is what? Block all traffic. Okay. The default action is block all traffic. So because of that, what is going on? That I'm not able to ping. Now I'll create a rule here that I want to allow inside to outside. And what do I want to allow? I want to allow ICMP. Okay, this is what we are going to do right now. Okay, so also I can show you that in the ASA we were having, like TCP UDP inspection is there and all. So that kind of concept also we don't have here. So if I try telnet also, I'll not be able to telnet right now. Okay, so what we'll do, first of all, we will try to allow ICMP. So my first requirement will be what? That this is my lab diagram and I want to allow the communication because by default it is blocked. So I want to allow the communication from inside to your outside. This communication I want to allow from inside to outside. So it will pass how? From here to here and this way. Okay. And what kind of communication right now I'm willing to allow here? I'm willing to allow here ICMP. Okay. So what about the reply traffic? Do you think I have to create a rule for reply traffic also? Yes. What if I don't create the rule for reply traffic? In that case, what will happen? If I do not create a rule for reply traffic, it will drop the reply. Then what is the use of connection table here? What's the use of connection table? We have a connection table, right? Difference between stateless and stateful firewall. What is the difference? What is the difference between stateless and stateful firewall? It will reply. Who will reply? Stateful, maintain the connection. So then based on the connection table entry, it should allow the reply, right? Okay. So let's go and create this rule. So click here, add rule. Now, when I will try to ping, so I'll try to ping from inside router to outside router. So which zone will be my source zone and which zone will be my destination zone? Yes, guys, which zone will be my source zone and which zone will be my destination zone? Inside will be source and outside will be destination. Correct. Okay, the destination zone will be outside. So now let's create this rule. So here I have to say that who is the source zone and who is the destination zone. And before this, I have to give a name to it. So let's say I'm saying allow ICMP from inside to outside. This is the rule name I have given. Okay. Now what? Who is my source zone? Inside. So either I can just drag and drop it, or else I can just select it and I can say like add to source or add to destination. So outside is what? My destination. This way also I can do it. Then after I have to give what? I have to give the network and also make sure what is the action. By default it is block. So right now I want to allow the traffic. So here the action is allow. By default the traffic is blocked. Now see here that here I have to give the source network and a destination network. So if you want, you can add it like this, that who is the source network? You can say 10.110/24 is my source network and you can add it like this. And who is my destination? So I can say 11.110/24 is my destination. This way you can add it, but this is not really a good practice. What is a good practice? That instead of directly defining the IP addresses here, you will create here objects. Okay. So these are some of the objects that are already there. And if you cannot find yours, let's say, for example, my internal network is 10.110. So I can see that, okay, I have a here an object that is for 10 000/8. Okay. But this is not my requirement. So what I can do, I can create a custom object also here. I can click on this plus and I can create an object. Now I can name it that this is what, this is my inside network. Okay. And then also I can mention here my IP address, like this is 10.110/24. This is the name. So name I have given so that when I will look here, I can easily know that, okay, which network it is. Okay, so here, then I can give 10.110/24 and I can say save this object. Okay, so now I can see here, I have the object inside network. I can click here and I can say add to the source network. Then same way I can do it for the destination also. I can click on this plus. I can say that this is my outside network. Okay. And 11.110/24. This is what I want to create. So 11.110/24. So this is my outside network, add to the destination. Now, when I was using, when I said that what I want to allow, so I want to allow the traffic from inside router to outside router only, not from inside network to outside network. I don't want to allow this thing that everything from inside to outside should be allowed. I want that only my inside router should have communication with the outside router. This is only the thing that I want to allow. So is my source network and destination network what I'm defining? Is it okay? Because it will allow everybody's communication, all of these inside R1, R2, inside PC, everybody will be able to communicate with outside R1 and outside R2. So it's not okay. My requirement is that only inside R1 should be able to communicate with the outside R1. Okay, so that means whenever we will create the object, individual IP addresses we will define. Okay, so let's go and define it. So the overall idea behind, showing you this thing is that we can create a single IP address in the object. We can give a range and we can give a subnet also. Okay, so let me remove it. And let me say plus. Then here I'll say inside R1 10.1.1.125. So when you give single IP address, you don't need to give the CIDR value. You can simply say okay. Okay. So this is my inside R1, add to the source. Same way, click on plus. Outside R1, 11.1.1.125. So this is 11.1.1.125. Save it. This is outside R1, add to the destination. Once this is done, right now we are not going with VLAN users or application ports or anything. So right now what I want to allow, which traffic? Do I want to allow all the traffic? No, right? I want to allow only ICMP. So I can go to the ports. Okay, and in the ports here you will find the protocol. In the protocol section, you can say what? ICMP. So click on ICMP. ICMP type code. So for request, what is the type code? 8. Okay. So if you want to allow only ACO request, then you can give this, or else you can say allow entire ICMP from inside to outside. So click on add. This is done. Then next thing you will do is that go to this logging and say log at the beginning of connection, log at the end of connection. This is very important step. Whenever you create a rule, always make sure you are generating logs for it. Okay, why? Because if there is any problem with your rule, so how you will come to know whether the rule is hitting or not hitting? So you can check the logs for troubleshooting. Okay, so generate the logs beginning and end. Just click on add. Okay, name is not valid. Is it too big? The name was big. So I'll say allow ICMP from into out. Click on add. Now this is the rule we have created here. You can see that source zone is inside, destination zone is outside, source network is 10.11.125. Here you can hover the mouse and you can see that, okay, from 10.11.125 to 11.11.125, and the protocol is ICMP, action is allow. Okay, and here you see this thing, that means logging is enabled. Okay, now once you have created this rule, you can just save it, and after saving we will deploy it. Okay, saved. Click on deploy. Select the FTD. Click on deploy. And then we can see the deployment is going on. Done. Once the deployment is done, now we can go and test the communication from inside R1. If I test communication, so if I say ping 11.11.125, do you see I have the communication? Deployment from FMC to FTD means we configure FTD from FMC and applying pushing the configuration to FTD. Yes, yes, this is correct. That in the FMC, basically it's a kind of template we have. So we just configure the variables in the template and we push that configuration to the relevant FTD. Okay. Even if you have multiple different FTDs or firepower devices to manage also, in that case, same sort of configuration you will be doing, whatever the device configuration you are doing, you will just push that configuration to your relevant device. That's it. Okay, so this is kind of a common template you can say. Okay, so now I have communication from inside R1 to outside R1. But what about any other type of communication? If I try, let's say telnet 11.11.125, you can see I'm not able to tell it. Okay, not able to tell it. If I try to ping 11.11.126, I'm not able to ping anybody else also. Why? Because against the rules, it's not matching my rules. Okay, so whether this traffic, I was able to ping earlier, so this traffic should match my rule, right? And in that case, if my rule is matching, I should be able to see the logs now. Okay, the logs should be there. So let me refresh it. Okay, go to the analysis, connection, events. Now here we will see the logs. So you can see that there was some traffic from 10.11.125 to, sorry, 10.11.125 to 11.11.125. Ingress zone. Guys, what is ingress and egress? What is ingress and egress? Ingress is inside and egress is outside. Okay, so kind of you can say ingress is what? Traffic is incoming. So on which zone the traffic was incoming? Inside. Egress means you can say the traffic was exiting. So through which zone or through which interface? It was exiting through the outside interface. Okay, so your source was inside zone, destination was outside zone, the application protocol was ICMP. Okay, so this way we can see details and you can see our traffic was matching the rules. Okay, now let's go back to the policies. Now let's say I want to allow SSH traffic. Okay, I want to allow that. Okay, my inside R1 should be able to take, okay, again understand the condition. My requirement is what? My inside router should be able to take SSH of outside R2. This should be allowed. And what is the protocol I want to allow this time? SSH. Okay, this is what I want to allow. From inside R1 to outside R2, SSH should be allowed. So let's go and create the rule for this. Now, right now, if I go and try to take an SSH, guys, how do we take the SSH access? How do I take the SSH access? What will be the command? SSH-L admin and IP address. Correct. Okay. So you will say SSH-L, then username. So username is what? Right now we have kept Cisco for the outside R2, and then IP address is 11.1.1.126. Okay. So right now if I try, I will not get an access because my firewall will drop the traffic. Okay, so right now I'm not having this access. And once we configure the rule, then we should have this communication. Okay, so not able to take an access. Let's go and create the rule. Okay, so click on add rule. Now source zone is inside, destination zone is outside, and name allow SSH inside R1 to outside R2. Okay, action is what? Allow. Then go to the networks. Now here inside R1, we already have it. For outside R2, I need to create an object. So inside R1, I have created the object already. Outside R2, we have to create an object. Outside R2, IP address is 11.1.1.26. So this will be 11.1.1.26. Save it. And then say outside R2, add to the destination. Now in the ports, what is the port number I need to add? What is the port number I need to add? So port number 22 in the source or destination? In the destination. Okay. So what you can do, you can search here if you can find, like I can see that here already SSH is there. So I can select SSH and I can say destination. What about the source port? What will be the source port value? In this case, what will be the source port value? It will be random, correct? Okay, and since it will be random, that's why in the source port, we will not define anything here. Okay, source port can be anything. Destination port is 22, that is SSH. Okay, and I will go and enable the login at the beginning, at the end. I'll say add the rule. Once we add the rule, save the changes and deploy it in the FTD. Deploy. Now wait for the deployment to complete. Okay, deployment is done. Now we can go to inside our room and I can try the same thing again. See, this time asking for password. I'll say Cisco, and you can see I have the access of outside R2. And if you want to verify who is accessing, you can use the command either show users or you can use the command who. So you can see, and in the location, it will give the IP address from where the access is being taken. So you can see the access is being taken from 10.1.1.125. Okay. Then after, we can go and check the events again. So we can see that one connection attempt was done from 10.1.1.125 to 11.1.1.26. It was going from inside to outside. The source port number was 45,190 and destination port was 22. Okay. So again, what was the action taken? The action taken was hello. This is clear. Yes or no? All right. So the next thing that we want to check is what I want is that my inside PC should be able to take HTTP access of DMZ server as well as the HTTP access of, let's say, R1 and R2. Okay, my inside PC should be able to take HTTP access of everybody, DMZ also and outside also. These two things I want to do. One is my DMZ server and my outside R1 and R2. Okay, so for this thing, I want to create the rule that my inside PC should be able to take HTTP of DMZ server as well as my outside devices, that is outside R1 and R2. Okay. So this time the protocol that we will be allowing is what? HTTP. What will be the port number? Port number will be 80. Okay. And if I want to allow HTTPS in that case, 443, correct. Okay. So right now, if I will try from the inside PC, right? Where is the inside PC? So right now, when I try from the inside PC, cancel. First of all, let me test connectivity. First of all, let me check the IP address itself. So I have the IP address, and since I'm having connection with the gateway, so I can see here network is there. Okay. Now what? So right now, if I will try to take an access of DMZ or outside R1 or outside R2, I'll not be able to take an access. So if I say http:// let's say 10.2.125, do I have an access? So I'll not have an access here. Why the access is not there? Why there is no access? Default all block, correct. So my firewall is blocking it. If I try 11.1.1.25, not able to access again. So definitely I'll not be able to access. Now what we'll do is we will go and take an access. I mean, we will go and create a policy here. So inside the policy, we are going to create a rule here that allow the, so see, I don't have to create different rules for DMZ and outside. In a single rule itself, I can mention two destinations. Okay, in one rule itself, I can mention two destinations. So let's go and add a rule. So I can say source zone will be inside and outside destination can be DMZ also, outside also. Okay. Allow HTTP from inside to all. Okay, I'm saying allow HTTP from inside to all. Networks. So my source network is what? Inside network. But I want to allow from inside PC only. So I'll say add it inside PC. IP address is 10.1.1.1. IP address is 10.1.1.1. Save it. So this is inside PC, add to the source. And my destination can be outside network. Okay, I'm allowing to all the devices. If you want to allow specifically to R1, R2, you can add specifically R1, R2 also. And for DMZ, I will add one more. That this is what DMZ server IP address is 10.2.2.125. This is 10.2.2.125. Okay. This is DMG server, add to the destination. Ports that I want to allow. So I want to allow HTTP. So I'll say add to the destination. If you want to allow HTTPS also, you can add this one also. Okay, so both HTTP and HTTPS will be allowed. And then enable the login. Click on add. The rule has been added. You can see from inside to outside or DMZ, from inside PC to outside R1, outside R2 or DMZ server. Two protocols, HTTP and HTTPS. Destination is, sorry, action is allowed. Okay, save this rule. Then deploy it. Select the FTD. Click on deploy. Okay. Once this is done, deployment is going on. Is it done? Now let's go and check. So first of all, let's test the HTTP. Colon / 10.2. Do you see it's asking username and password? Cisco. And we can see what we are accessing right now. DMZ server. And here we can say show IP HTTP server history command. And this command will give us that, okay, who is accessing? 10.1.1 is accessing right now. Okay. Same way we can go and check HTTP / /111.125. Cisco. Save. Show IP HTTP server history. Here also you can see that this is outside R1 and who is accessing 10.1.1. Then R111 126. Cisco. This is outside R2. Who is accessing? 10.1.1 is accessing. Okay, so this was HTTP access. Now let's try HTTPS. HTTPS / 10.2.125. So in this case, your browsers will give you some problem. Your newer browsers, they do not support older encryption protocols. Okay, your router has an older protocol, so it says SSL error is there. Okay, it is not saying that you cannot access, it's just saying that this particular IP address cannot communicate securely with the peer. Why? Because there is no encryption algorithm. Okay, so this is the problem. In the Firefox, you will not be able to access. And what about your Google Chrome? So if you check 10.2.2.125, so even Chrome will say that this site cannot provide a secure connection. Why? Because it is using an unsupported protocol. So either the SSL version or cipher mismatch is there. So how you can verify? You can use the Internet Explorer. This is an old browser. Okay. So from here I can try https://10.2.2.125. Ask me later. It says is correct. This is definitely correct. Okay, so it says turn on TLS 1.0, 1.1 or 1.2 in the advanced setting or try connecting to again. So let's check what is it. TLS HTTP 1.1. Okay, these are already checked. So let's use SSL also. Apply. Okay. So this is because of that only, that the encryption protocol is creating issue. Okay. So this is not a connection problem, okay? Here you can see we do have access, but it's saying that it is not providing a secure connection. So we'll not be able to see it. Even the same thing for 11.1.125. Okay, and same thing for 11.1.126. Okay. So right now communication is there. If I go with the HTTP, you will be able to see the same thing. 10.2.2.125, or this is HTTPS. So you can see with HTTP, I have the access. Okay. So here we cannot verify it, but in the events, in the logs, we can go and verify that. If I show you the logs, analysis connection events. So you will see that, even the connection to the port number 443 was allowed. Okay. So you can verify, see here, there was connections made from 10.1.1.1 to 10.2.2.125. Okay, multiple connections, all were the HTTPS connections, and the action was what? Allowed. Same thing here, you can see that we were accessing again 10.2.2.125, 11.1.1.126. All actions were what? Allow only, and the protocol was HTTPS. You can see port number 443. Is it clear? Yes or no? Is it clear to everyone? Okay, great. So now I believe you guys got an idea how you will be creating the rules for communication. Okay. So now we have a task that from outside R1 to inside R1. Okay. From outside R1 to inside R1, you have to allow SSH. Okay. Then from outside R2 to inside PC, you have to allow ICMP. Okay. And from inside R2 to DMZ, you should allow telnet. Okay. Then From DMZ to here, you have to allow terminate. Okay. And the same thing from outside R2 to outside R1, you have to allow terminate. Okay. Then from inside PC to DMZ, you have to allow STD. Okay. This is the task that you have to do. Note it down. Okay, or you can take a screenshot. This is your task that you have to complete. Done. Okay. So guys, this is it for the day. Today, you guys practice these policies, and then tomorrow onwards, we'll start with the next concept. Okay. All right. Any doubt in today's part, you guys can ask. No doubts? All right. Okay, guys, then I'll see you tomorrow. While doing lab on EvenG from home PC, can we use our laptop desk? Yes, you can use it. You can use it. Okay. Try to use it as a management PC. That will be much better instead of inside PC. Yeah. Okay. Okay. All right, guys, then I'll see you tomorrow. Have a good night. Okay, guys. Bye.